Hi, in today's video I would like to share with you a very nice problem of Spanish Mathematical Olympiad 1995, question number 4. Okay, here is the following information. Given a prime p, find all integers x and y as integers numbers such that we have this product p as a prime is multiplied by this sum x plus y equal to x is multiplied by y. Okay, this is very nice problem, but it's very full with tricks. Okay, so kind of symmetry here. If you take a look at this product, x plus y equal to xy. Okay, if xy is a solution, that means y and x is a solution as well. Okay, the hint that I'm going to give to this problem, you have to do all the cases. Okay, when you have x equal to y and x is strictly superior than y and x inferior strictly than y. Okay, because this is the best way to solve this problem. Then we take a look when you have a prime as an even number and when you have the prime as an odd number. Okay, go ahead, pause this video if you would like to give that try to this problem. When you are, come back to see the full solution. Okay, let's get into the solution. We have this product p is multiplied by x plus y equal to this product x is multiplied by y. This one equivalent to this fraction p equal to x multiplied by y is divided by x plus y. Okay, if you take a look at this fraction, we have a nice symmetry here. So that means xy is a solution and y and x is a solution as well by symmetry. So without loss of generality, x and y is solution, and also y and x is a solution as well. So if you take a look at this fraction again, p as a prime equal to this fraction, this one is superior equal to 2. Okay, since we have a symmetry here, that means x and y must be positive numbers or both numbers must be negative. Okay, if x and y are positive, that means we are good to go. If x and y are negative, here is a problem. But here is a problem. If x is negative and y is negative, when you apply the product of both numbers, is giving you positive. Okay, the positive divided by the sum of these numbers, which are negative minus negative is giving you negative. You will have the positive divided by negative, which is impossible because we have a prime as a positive here. That means impossible to have x and y as a negative numbers. That means x and y are absolutely positive numbers. Okay, so that means x is positive and y is positive as well. Now we were to solve our equation by taking the first case as x equal to y. Okay, so the case number 1, let's set x equal to y. I'm going to replace y with its value into this equation. I will get p is multiplied by x plus x, I get 2x, equal x is multiplied by x, I get x squared. Since x is strictly superior than 0, I'm going to cancel out x from both sides. I will get x equal to 2p. Okay, here is the first solution in terms of p. I'm going to determine y. Since x equal to y, that means x equal to y equal to 2p. Here is the first solution, x equal to 2p and y equal to 2p. P is a prime. Okay, now let's do the case number 2. Case number 2, if x strictly superior than y. Okay, I have this equation, p of x plus y equal to x is multiplied by y, equivalent. I'm going to factor out this one. I will get p of x. I'm going to pull out p of x and taking p of y to the other side of this equation. In the same time, I'm taking y as a common factor. So we'll get p of x equal to I'm putting y as a common factor. Y is multiplied by x minus p. Okay, here is the first equation. I'm going to do the same thing. Since I have a symmetry here, I'm going to pull out py instead px. I will get py, p is multiplied by y, equal to x is multiplied by y minus p. Okay, here is the second equation. Now I have x strictly superior than y. I'm going to add y on both sides. I will get x plus y strictly superior than 2y. Then I'm going to multiply both sides by p. This term equal to x is multiplied by y. Okay, this one equivalent, x is multiplied by y strictly superior than 2 times yp. Okay, since y is a positive number, I'm going to cancel y from both sides. I will get x strictly superior than 2p. Okay, now I have this term x is strictly superior than 2p. So the next thing that I'm going to do now, I'm going to multiply both sides by y minus p. So this one, I will get x is multiplied by y minus p, strictly superior than 2p is multiplied by y minus p. So x is multiplied by y minus p equal to p is multiplied by y. I will have p is multiplied by y strictly superior than 2p is multiplied by y minus p. I'm going to simplify this one more. I will get p y strictly superior than 2py minus 2p square. Okay, I'm taking this 2p square to the left hand side of this inequality and bring back py to the right hand side of this inequality. Okay, this one is giving us 2py strictly superior than 2py minus py. I will get py. As I'm taking this one to the right hand side of this inequality and subtract this one from this one, I get this one. Now I'm going to take off. Now I'm going to simplify p from both sides. I will get 2p strictly superior than y. Okay, in the other word, y is strictly inferior than 2p. Okay, it's the same thing as this one. Now I get new inequality. Okay, since y is strictly inferior than 2p. Now we will have two subcases. When we have p equal to 2 as a prime, the second subcase when we have p is strictly superior than 2. Okay, so let's put subcase number 1. If p equal to 2 as a prime, this one I will have y strictly inferior. I will have y strictly inferior than 4 because I'm taking p equal to 2. Okay, so this one y, I will have 3 cases. I will have y equal to 1 or 2 or 3. Okay, because 0 is eliminated because we already have y strictly superior than 0. Then I will have this one strictly inferior to this one. I'm taking y, I'm taking 1 2 3. Okay, now if y equal to 1, okay, so I have this equation, p is multiplied by y equal to x is multiplied by y minus p. So by replacing p with 2 and y with 1, I will get 2 here equal to x, y equal to 1 minus 2. I will get here 1 minus 2 equal to minus 1, which is minus x. It's impossible to have 2 equal to minus x because since x is strictly superior than 0, impossible to have this solution. It's impossible. So let's move on to the second case. y equal to 2. Y equal to 2, I'm going to replace 2. I'm going to replace y with number 2. I will get 2 as a prime is multiplied by 2 equal to 4, equal to x. Y is equal to 2 minus p equal to, which is 0. That means 4 equal to 0 is impossible. Let's move on to the third case. When we have y equal to 3, this one implies I'm going to replace y with its value. I will get 2 is multiplied by 3, which is 6, equal to x is multiplied by 3 minus 2 equal to 1. Okay, that means x equal to 6. X equal to 6. Now I will have one solution here. X equal to 6 and y equal to 3. When we have x strictly inferior than y, by symmetry I will have another solution, x equal to 3 and y equal to 6. Instead to take x equal to 6, we take in x equal to 3. Now let's clean up the board and move on to the next case to do the when we have prime number is superior or equal to 3. Okay, so the case number 3, when we have x strictly superior than y and p strictly superior than 3. If you take a look carefully at this equation, now p as a prime became as an odd number. Let's assume x is a odd. If x is a odd, is multiplied by odd, is given as odd. That means the right hand side of this equation must be odd as well. Let's check this one. X is a odd minus odd is given as even. So y, whether is odd or even, we still have even here. It's impossible to have one side is a even, the other side is a odd in the same equation. Okay, that means it's impossible to have x is an odd number. Okay, let's assume x is a even. If x is a even, since p as a prime is a odd is multiplied by even is always even. That means the right hand side of this equation is a even as well. Since this one is a even, that means x is a even minus odd. Okay, even minus odd is given as odd. To have even number, we must give y even. Okay, to have even number, y must be even, because even is multiplied by the odd is given as always even. Okay, so that's mean y is a even. Finally, x and y are even. Okay, we have x is strictly superior than y, and we have this inequality, y is strictly inferior than 2p. Okay, since we know x and y are even numbers, if we take in number 1 is strictly inferior than p. Okay, minimum number can take p is number 2. That's mean 1 is strictly inferior than 2. If p equal to 2 as a minimum number can take, okay, always 1 is strictly inferior than p, whatever p is. Okay, let's take number 2 here. We'll replace p here. I'm going to add p on both sides. I will get p plus 1. Okay, so as we know, this is 2p. We have 2p here. Since y is an integer, y is strictly inferior than 2p. By using the private solutions that we found before, we found y equal to 3 as a first solution. This one can be written on this form. 2 is multiplied by 1 plus 1. Okay, when we had p equal to 2. Okay, then this one equal to this one, which is p plus 1, which is strictly inferior than 2p. Okay, when we have p equal to 2. And also we're using the fact when we have x equal to 6, which can be written on this form as well. 2 to the 2 plus 2. 2 to the 2 equal 4 plus 2 equal to 6. This one also when we have p equal to 2. Okay, we are using these three facts in order to find general solutions. This one, it was found when we have p equal to 2, but now we are going to find the general solution when we have p is superior or equal to 3. When we have p superior or equal to 3, then x and y are even. Okay, since are even, this one can be transferred into the general solution, which is like p square plus p. Okay, let's check this one. If we will replace 3 with this one, I will get 3 square, which is 9, plus 3, which is 12. 12 is an even, okay, as we have here. Same thing with this one. If you replace p with the number 3, you get 3 plus 1, which is 4, which is even as well. And also, by using this fact, x is strictly superior than y, then x will be replaced with p is multiplied by p plus 1, which is equal to p squared plus p, which is strictly superior than p plus 1. Okay, this is x, this is y. Now we found the general solution of this one. What's left now? I'm going to check these solutions by plugging these two solutions into this equation to check they are verifying this equation or not. Okay, we have p as a prime equal to x is multiplied by y is divided by x plus y. By replacing x with its value, I will get p squared here plus p is multiplied by y, which is p plus 1 is divided by p squared plus p plus p plus 1. By taking p as a common factor here, we'll get p plus p plus 1 quinary square. Okay, is divided, this is p squared plus 2p plus 1, this is p squared plus 2p plus 1, which equal to p is multiplied by p plus 1 quinary square is divided by p plus 1 quinary square. Okay, by simplifying p plus 1 quinary square from numerator and denominator, we'll get p. Okay, which is the same as we have here, p equal to p. That means our solutions are verifying this equation. Okay, here is the following solutions. I get x equal to p squared plus p, and we have y equal to p plus 1. But don't forget, by symmetry, when we have x strictly superior than y, we found these solutions, but when we have x strictly inferior than y, we will find the same, we will find another solutions, which is x equal to p plus 1 and y equal to p squared plus p by symmetry. Okay, because by symmetry we found again another solution here. So another solution, which is x equal to p plus 1 and y equal to p squared plus p. Okay, here is three general solutions that we find are verifying this equation. Okay, so I have proven this one. If you are interested watching this one, just don't forget to support us with your like and subscribe. Thank you for watching. I will see you in next video. Bye.